Alright, AP Chemistry, this is a continuation of the solutions for Wednesday, October the 7th. It's day 27, and it's lesson 12. Alright, so problem number 2. So this is a combustion reaction between ethylene, a hydrocarbon, and oxygen, producing carbon dioxide and water, as all combustion reactions do. Alright, so the question is, how many moles of H2O will be produced by 3 moles of CH4? So you want to know moles of H2O, that's your question, so there's a question mark right there. Will be produced by 3 moles of CH4. So here's 3. So this is a one-step problem. You're already in the formula on the chemical equation, and all you need to do is move across. You can only move laterally or sideways inside the chemical equation, and that's where we start, so that's where we're going to end right there. So over here, and the relationship is 1 mole CH2 for every 2 moles, 1 mole CH4 for every 2 moles of H2O. One mole of C2H4 for every 2 moles of H2O. Alright, so one step, we need to get rid of moles of C2H4 and come up with moles on the top of H2O. So the one that does that is this one right here. Moles of C2H4 cancels with moles of C2H4. This is our final unit of measure. So 3 times 2 divided by 1 is 6, and that's the final answer. Alright, next up. How many grams of CO2 will be produced by 3.667 grams of C2H4? So grams, how many grams of CO2? So here's CO2, grams is down here in our world, and we're going to start with 3.67 grams of C2H4. So that's a 3-step problem. To have a relationship between these two, we have to be inside the chemical equation. So we move across the molar mass into the chemical equation from C2H4, moles of C2H4 to moles of CO2. Once we have that, then we come out through molar mass to the grams of CO2. Now in this problem, I did not include the molar masses, so I'm going to ask you to compute those. That's pretty easy. Some of these you might have memorized fairly soon. So C2H4. C2 is 12.01 times 2. That's 24.02. And then 1.01 times 2 times 4. That's 4.04. So 24.02 plus 4.04 is 28.06. Okay, O2. Now be careful, you're not giving the mass of 3 O2s. You're giving it always, a molar mass is always 1 mole. This is 3 moles. That comes into play if you need to use it in the equation here, but you're interested in 1 mole. So O has a molar mass of 16 grams, and you have O2. So O2 has a molar mass of 32 grams. CO2 we've done a few times before. O2 is 2 times 16, just like this, that's 32. Then you add 12.01 for carbon, and that gives you 44.01. And finally, H2O, you might have memorized by now, it's 18.02, 2 hydrogens and 1 oxygen. Alright, so let's go ahead. So we're going to start with grams of C2H4. And this is going to be a 3-step problem, so I'm going to write it way off to the left here. And we want to end up with grams of CO2. Okay, so the first conversion is going from grams of C2H4 to moles using the molar mass. So the molar mass is your conversion there. Okay, you got to choose one of the ratios. We need grams of C2H4 to cancel out. It's on the top here, so it has to be on the bottom. So it's going to be this one right here. Grams of C2H4 cancels with grams of C2H4. All right, next, draw a line here to separate these. We've got to go across the chemical equation from moles of C2H4, where right now we're sitting right here. We now have to go from here to here. So there's 1 mole of C2H4 for every 2 moles of CO2. So I'm just going to write the ratios at this point. Okay, which one of those there? You need to get moles of C2H4 here to cancel out because it doesn't appear in the final answer. So that means it has to be on the bottom, so you're going to use this one. Moles of C2H4 cancels with moles of C2H4. And finally, the last one is going to be the molar mass to get from moles of CO2 out, moles of CO2, out to grams of CO2. You got to use that molar mass. So I'll just write the ratios of that. I'm running a little short on space again here. Okay, so we need moles of CO2 to cancel out and grams of CO2 to appear in the final answer. So that's going to be the second one down here. We're going to put that up there. Moles of CO2 cancels with moles of CO2. Last man standing is grams of CO2 right there. So now we're ready to do the numbers. 3.67 times 1 times 2 times 44.01 divided by 28.06 divided by 1 divided by 1. Okay, so we can use looks like we can use 3 significant figures. We're limited by 3.67. And the answer I get is 11.5. All right, how many grams of O2 is required to produce 8.3 grams of CO2? So it's grams to grams. That's going to be another 3 conversion problem. So grams of O2, so that's we're down here. The grams and O2, and 8.3 grams of CO2. So 8.3 is over here. So again, the chemical equation is flowing left to right, but our math equation is flowing from what we start with back to what we're trying to get. What does it take to give us this much CO2? So we go up into the equation through molar mass, come over across inside the equation, and then come back out through molar mass. Three conversions, so we'll draw the boxes. Okay, there we go. Trying to find grams of oxygen. Okay, first conversion. Molar mass of carbon dioxide. Okay, which one of these two goes in here? We need grams of CO2 to cancel. That's on the top, so we need the one with grams on the bottom. That would be this one. Gram CO2 cancels gram CO2. Next one, now we're inside the chemical equation. We're right here. We need to get over to over to here, for oxygen, right there. So it's 2 CO2s for every 3 O2s. So you just write it exactly as you see that. Okay, we need moles of CO2 here to cancel out, so it doesn't appear in the final answer. So moles of CO2 is on the bottom on this one, so that's the one we're going to use. Moles CO2 cancels moles CO2. Finally, we need to get out of the equation. We're now right here in moles of O2. We need to use the molar mass of oxygen to give us the grams of oxygen. So there's the conversion, 1 mole, 32 grams. So I'll just write the ratios here. All right, so we need moles of O2 to cancel out, grams of O2 to appear on the top for the final answer. That's going to be this one. Moles of O2 cancels there, and moles of O2 cancels there. Grams of O2 is the last unit there. So now we're ready to run 8.3 times 1 times 3 times 32 divided by 44.01 divided by 2 divided by 1. Okay, and I get 9.052. I have only 2 sig fig right there. No, that's okay, because that's that's okay. I have only 2 sig fig in my starting number there, so I'm gonna limit that to 9.1. All right, let's keep going. How many moles of O2 are required to make 12.52 grams of H2O? So you'll start to recognize that moles to grams is a 2 conversion problem. So it's how many moles of O2. So moles of O2 is right here, O2 and in the moles row. Is required to make 12.52 grams of H2O. So H2O is here, grams is in our world here, so it's 12.52. Okay, so it's hard to read this here. There's the question mark right there. So you need to go from 12.52 into the equation and then across over to moles of O2, and you're done. 2 conversions. All right, so our first conversion is going to be the molar mass of water. It's going from here to here using that. So it's 1 mole for 18.02. At this point, I'll just write ratios. That is a 2. Okay, I have grams of H2O on the top, so I need grams of H2O on the bottom. So we're going to use this one. Grams of H2O cancels and cancels. Okay, next one is going to simply be the moles to moles. It's going to go from 2 moles H2O to 3 moles of O2. All right, so to cancel out, and moles of O2 to appear on the top. So that's going to be this one. Has moles of H2O on the bottom and moles of O2 on the top. Moles of H2O cancels. Moles of O2 is the final unit for the answer. So it's 12.52 times 1 times 3 divided by 18.02 divided by 2. And I get 1.042. I can 4 sig fig there, 4 sig fig there. These are all unlimited sig fig. So I can do 4 significant figures. So I can do 1.042. Okay, and that takes care of that. Okay, last one. We're going from grams of O2 to moles of H2O, so that's 2 steps, grams to moles. So let's look at what that is. So it's how many grams of O2, so down here is grams of O2, how many? And 5.67 moles of H2O. So 5.67 is up here in the moles row, and it's underneath H2O. So we start here, and we need to get here, so we come across the equation to moles of O2, and then we come out using molar mass. Two conversions. Okay, so the first one is between moles and moles of water and O2, so there's 3 moles of O2 for every 2 moles of H2O. I'll just write that as ratios. Okay, so we need moles of H2O to cancel out, so it's on the top there. It has to be on the bottom here, so we're going to use this one. Moles H2O cancels moles H2O. Then the next one is moles of O2 coming out to grams of O2 for our final answer, and there's the molar mass conversion right there. Okay, we need moles of O2 to cancel out and grams of O2 to appear on the top, so it's going to be this one. Moles of O2 cancels, moles of O2 cancels, grams of O2 is our final answer. So it's 5.67 times 3 times 32 divided by 2 divided by 1. And let me be precise here. It's 32.00 according to our periodic table. That'll affect the significant figures at the end of the problem. So 5.67 times 3 times 32.00 divided by 2 divided by 1 equals 27.216. I have 4 significant figures here. I have 3 here, so we're limited to 3, so it's 27.2 grams of O2. Okay, hopefully these problems, which seemed overwhelming, yesterday, are starting to kind of make sense how you do these. The graphic organizer, I hope, will help walk you through them, and then you get to where you don't need them. You don't need to write all of this. Trust me, when I do these, I write a lot of it. I do write out the equations. Yes, I don't write out all this. I can do this part in my head, but this part, I absolutely write out the equation. That is required. Okay, this is the second problem. I'm going to wrap this so I can get it up online. I'll do the next problem, problem 3, on a different video. They'll just all be together inside the assignment for this particular unit. You just have to open them up as separate files. Okay, so I'll see you on the next lesson.